Like to welcome Anish Karv, Chief Technology Officer of Quill Data. He's an expert at transforming scattered, unlabeled data into reproducible, discoverable, and trusted datasets in the cloud. Now, Anish will delve into reusable models with immutable data lineage. Over to you, Anish.
Thanks, everybody. Nice to meet you. As was mentioned, am the CTO at Quilt Data, and we really spent the last 7 years of our existence thinking about immutable data and doing that in the open source. So everything I'm going to share with you today is actually available for you to practically apply in your enterprises immediately. And I want to highlight this word reusable because I think it's the most simultaneously the most valuable and the most difficult word to achieve in FAIR. And we found that reusability boils down to 3 dimensions: versioning, so data versioning, the same way that we have code and environment versioning, verifiability, and visualization. And we're going to talk about all 3 of those dimensions today. I want to zoom out for a second and just, if we think about cloud as a whole, for all of the dozens or hundreds of Amazon and GCP services, at a virtualization layer, there are really only 3 different things going on. There's network, there's compute, and there's storage. And I want to dilate on the storage component here for a moment, because a lot of our serialized models, our training sets, our test sets, our validation sets, all go in a storage layer, often Amazon S3. And the first challenge that we find in getting to FAIR is that S3 stores data, but it doesn't really manage it. You can't even sort sometimes files in the S3 console. There isn't really a built-in search facility. So S3 is certainly lacking quite a bit of convenience. And there are a variety of data management scenarios when we are training models, or even if we want to spot check the output of a model, that we run into immediately. So files can be moved, deleted, copied, renamed, orphaned. And the joke that I like to tell here is S3 is kind of like a write-only database. So you put data in it, but again, here's this keyword reuse. You rarely emerge data for reuse across teams, across time, across collaborators. And the other issue, that I find is a usability barrier for blob storage is that models, as you build models, as you run statistical pipelines, data is a team sport. And that means that not everyone who's on that team is a developer, or not everybody who's on that team actually wants to write code. And so what happens is some of our training, tests, and validation sets, or information that we need to shepherd the model to maturity, gets siloed into other systems: Box, Ignite, Dropbox, email. And the reason for this is different skill sets in the enterprise. So one of the problems that we'd like to solve, and we've done this in open source, is improving the usability of blob stores so that cross-functional teams can work together to mature models. The other missing issue from blob storage is really this concept of provenance or lineage, is where did these files come from? So how many people have had the experience of, you trained a model, oftentimes at great expense. So it took hundreds or thousands of compute hours on very expensive compute instances to produce the model. And 6 months later, you want to reuse it. Well, it's very painful. You just pull this dusty serialized model off the shelf and well, where did this come from? Should I even trust this model? And what ends up happening most of the time is people just, oh, well, let's retrain the model with slightly different parameters, because they can't trust the work that they've done. Excuse me, even though they've captured the serialized model, the output of that training process and that compute process, there's no support in systems like S3 for provenance and collections. And I guess the collections concept is, sure, S3 has object version IDs, but how do you create a comprehensive collection, like a test set, a training set, a validation set, or a model which is in the context of the training set that it was used to produce it? And I want to kind of zoom out here for a moment and just think about the FAIR journey. And here's the interesting thing, especially if you have cross-functional teams, which are really common in biopharma. I think they're increasingly common in ML. What is an example? You may have product managers, you may have executives or leadership teams that want to look at the output of the model or understand how it's performing, understand what might be causing drift. And these teams really encounter a lot of shame because, they don't know necessarily how to run TensorFlow. They don't even know necessarily how to go into S3 or how to even spot check the outputs of the model, or the classification outputs of the model. And I guess I want to get to, we're all familiar, I think he was one of Steve Jobs' favorite reviewers and one of the first people to review the iMac. And when Walt Mossberg started his technology, he made this important emphasis that it isn't the user's fault if the systems aren't easy to use, right? That's the burden on the system designers, on all of us, those who are implementing and deploying platforms inside of enterprises. And this is where I want to talk about some of the limitations or some of the things that make FAIR, findable, accessible, interoperable, reusable, difficult. So the first thing is FAIR is a destination. It does not tell you how to get there. And the second is a lot of teams feel intimidated by this. And we're lucky to work with a variety of different enterprises. And I can't tell you how many times we've got on a call and the customer will tell us, well, our data aren't fair. And so this is kind of the dark side of FAIR, is that customers just end up feeling bad about their data and not knowing how to get to the other side. And I think it's important to acknowledge that reality is often foul. So what people actually feel about their data is fragmented, overwhelming, uncertain, and lost. And I'll get into the code particulars of how we overcome these problems, but I think it's really important and actually a natural extension of this recent conversation that we were just having around what can humans do versus what can machines do. It's really important to acknowledge the human side of this equation and how people often feel overwhelmed and uncertain about the data that they have, and consequently about model provenance. Like, I'll repeat myself, you pull a model off the shelf, how do you know you can trust that model? Or should I just say, screw it and retrain? So what is needed here to get to fair data as an industry is a new mental model. And the first thing I want to point out is that enterprise is missing a standard data container. So the concept of containers, you're all familiar. Docker drew inspiration from the shipping container, and the revolution of the shipping containers, that shipping throughput went way up because regularity went way up. So everybody in a shipping yard knows exactly how many containers can go on a given ship. And that means that you can maximally pack those ships. And the container doesn't care if it contains toys, electronics, pet food. It really makes absolutely no difference. There's now a standard unit of transaction. And what we've really been focused on at Quilt for the past 7 years is what does a standard data container look like? And we've come up with roughly 5 dimensions that we think are important. So one is immutability. And any of you that use systems like Git or Docker know what immutability means. It means that the contents cannot change without the hash also changing. So that hash is, in some sense, it's not a proper semantic hash, but that hash is tied to the contents of the data or the container or the code commit that you have. So immutability is the first most important thing. And this is really the cornerstone of good modern functional data engineering, is your components should all be immutable so they're repeatable. The second one is human readability. It's not just enough that you store the data and the data can't change. People who don't write code or people who don't have time to write code need to be able to go in and spot check and understand the data. The container should be structure agnostic, right? This is one of the big problems with databases, even schema on read databases, is that they only kind of accommodate structured and semi-structured data, but a lot of the data that we're generating, images, text corpuses, these are all totally unstructured. So the container should be structure agnostic. It should be logical as opposed to physical. What does that mean? This is kind of the difference between a URN and a URL. The logical name should be abstracted away from where things sit in physical storage. And we'll talk more about that later. And it should be validated, right? So in any regulated industry, for instance, GXP in biopharma, there has to be a validation process where you can prove to your auditors and you can prove to the people inside your company that this data has not changed since it left the instrument or since it came out of the training pipeline. And I guess my main point here is that immutability makes iteration and compliance easier. Why does it make iteration easier? Well, anybody within your company, and I'll give you specifics of how you do this both at the API level and theoretical level, can reproduce any model you've created, and compliance becomes easier because compliance is essentially the process of proving that you did what you said that you did. And if the record of everything, all the artifacts, models your company has produced are immutable, you can simply go back. You have this immutable data lineage and you point to, this is how it was on January 1st, we made this decision. And the process of compliance, whether you're in automotive or biopharma, gets much, much easier. And we can talk more about specifics in the question. So the other thing is that as scientists and as experimental teams, we're constantly tweaking things. And this fear of files changing came from a world where change was very expensive, or it was potentially irreversible, and memory was very expensive, or disk was very expensive. And we live in a totally different world now. Now that we have immutable components, think about this. Many of you are developers, so think about Git for a second. What is the actual thing that Git contributed to the world? That branching became cost-free. So it's essentially free to branch data. And that's what, to code in the Git world. But in the data world, we want people to be able to make experiments very, very cheaply. And guess what? If this golden master, this thing that we produced as a company, is known immutable, I can tweak the heck out of it and never damage the immutable parent. So the key thing here is that immutability means, even though it means nothing can change, immutability actually means that your company can experiment freely and scientists and stakeholders are free to change things because they know that the original is always going to be intact. And we like to think of immutable links as a data chain of custody. So from the training environment to the model to the scientist, from the instrument to the scientist to the filing. And what immutable data really allows you to do is to build up this immutable chain of custody. The trick here, I think, from a technical perspective, is how do we unify unstructured, semi-structured, and structured data? And this is really the trick that we got from building around blob storage. And so if you think about it for a second, if you need to assume, so let's think about your feature store, for instance. If you want to base that on, if you want to use a database for your feature store, you're going to have to come into contact with the schema of that database, and you're going to have types for all your columns. But the beautiful thing about S3 and blob storage as a whole is that it is totally structure agnostic. And in ML, our training sets and our test sets and our models are often highly heterogeneous. What does that mean? I could have my loss data in a CSV file. I could have 10,000 images, and I could also have a serialized model. And those are all at different levels of structure. And the beauty of blobs is they can literally be structured, semi-structured, or unstructured. And this is what we've done in the open source, is really built on top of the S3 blob storage and create a package manager for S3. Why is this important? Let's think for a second here about how we go out and get reusable building blocks for code. How do you install TensorFlow? Well, it's much worse than this, but in a perfect world, it's just pip install TensorFlow, right? Or pip3 install TensorFlow. And so now the question should be, how do you get reusable data sets for training? And we set out to answer this question. And this is our open source package manager. It's completely royalty free. You can go out, you can fork it, you can clone it. And this allows you to do really neat package managery things on top of data, not code. And so I want to give you some examples. So whenever you want to materialize a dependency, so let's say that you want to train a new model and you want to warm up the training set on disk, you just pip install Quilt3 is how you would inquire the package manager, but then you would, let me jump ahead here, you would Quilt3 install the specific data set that you want to install. This foobar is a logical name, and this top hash is the hash of all the hashes of the objects in the data set. That's a very fancy way of saying is you have the ability to pin your data dependencies. And this is critical to reproducible training machines, because if you can't reproduce the training set, you're never going to be able to get the same model out. So this is really the concept of pin data dependencies, and it's the third missing piece from the industry. Just to back up and show you what this slide was about, this is how you create a quilt package. It creates that package by pushing data into S3, and then this is how you materialize or copy that package down. And there are a lot of in-between APIs like Browse, which allow you to just inspect the metadata of the package without actually materializing any of the data dependencies. Oops, let's see here. So the way to think about the processes in your organization that produce models, this is nothing new. It's a standard computer science concept. You see it in products like Airflow and Dagster. I just want to generalize it a little bit, is that every process in your organization consumes data in the form of packages and transforms data in the form of pipelines and produce packages as outputs. So what does that mean? This means that all of a sudden the nodes in our process are data packages, the edges are pipelines, and now we have a very principled and repeatable way of building every artifact that our organization produces with a directed acyclic graph. And this is a tremendously powerful idea. Why is it powerful? First, debugging just got 100 times easier because everything's built from immutable components, so I can reproduce everything in a local environment. Second thing, collaboration. Across time, reusing a model after six months, across machines or environments, taking a model from AWS into GCP, or across people, across collaborators, right? So like somebody leaves the company, how did they build this model? I don't know. Well, now you're going to solve that problem forever by thinking of everything as a pure function of code, environment, and data. And this is a little bit of what we call the GDQ stack. So Git for code, Docker for environments, data for Quilt. You can have more hashes as well. There's nothing to stop you, but this is kind of the simplest core that I can offer you as a repeatable pattern in your company. What is a pure function? A pure function is when given the same inputs, will always produce the same output. And so when you think of your models as pure functions, you now have a guaranteed recipe that works every single time by virtue of mathematics and how SHA-256 or how cryptographic hashes work. To reproduce, you have a bulletproof recipe to reproduce and to prove for compliance any artifact within your organization. That includes models, it includes training sets, and things like hyperparameters that should all be recorded as part of this pure function. So what does this mean? This means that model governance, the process of governing models, is about models with their full context. What is context? The documentation for how you use the model, the training set that produced the model, the hyperparams that produced the model, the commit message, right? The human reason why this model iteration was produced. Hey, this is a drift from production, or, oh, our training set was skewed. And then finally, the model itself. So what does this mean? This means that nobody should be storing serialized models in isolation in S3. Your model should be packaged in the full context that produced that model so that you have trust, compliance, and this directed acyclic graph within your organization. You can think of packages as augmented execution contexts. So a quilt package is data, metadata, charts, documentation, and lineage in one construct. And the beauty here is that nobody gets models right the first time. So what does that mean? That means that the same way Git made code experimentation easy, we've tried to make S3 buckets like branches in Quilt so that you can divide your data domains into different levels of quality. You have raw data, refined data, and curated data. And this means that you can have a process for iterating on your models, and you can use metadata quality workflows to gradually harden the schemas of the contents of the models and your training sets over time. So again, the key idea here is that a package is a data, metadata, charts, documentation, and lineage, also known as data plus its full context. So the model, the serialized model, plus the training set, plus the hyperparameters, plus the documentation. And that you can use that to gradually attain greater accuracy and gradually attain production models and track the life cycle of these models across different buckets in S3, right? So what you don't want is a single blob store where literally everything is happening in different folders. That's very confusing. You want different domains of data quality so that your model can mature over time and go from bucket to bucket or from lifecycle phase to lifecycle phase. The next thing I want to show you is a little bit of the human readability of data packages. And the key thing here is that data aren't true at the organizational level until people on a cross-functional team agree. So it's not just enough to run TensorFlow. It's not just enough to run Docker. It's not even just enough to create a Quilt package. That has to be viewable and reviewable by other humans in your organization. And I want to this is also available in the open source. It's just Quilt 3 space catalog. And I want to just break out and do a quick demo, if I can, of what a Quilt package actually looks like. And the key thing here, first of all, is that all these packages are code accessible. So you can interact with them in Python, you can interact with them with CLI. And again, from this versioning and immutability standpoint, every package has a revision history or a lineage with a human comment at each point. And you have these immutable URIs, which can go into your compliance systems and which can go into your systems of record. And the cool thing is this really short URI, or you can also do this with a URL. This really short URL points to a data set of unlimited size in Amazon S3. And so this is a little biopharma specific example that we have, but it should be really easy to bake visualizations. So if you're running genomics pipelines, for instance, you want to visualize the genome tracks, it should be just a couple of lines of code to do that. And the package format allows for this. Remember, we talked about verifiability, versioning, and visualization. I'm just showing you some of those 3 V's in action. Another example here is, you can obviously post readmes in your data sets. This is critical for humans to reuse them over time as people leave the organization, as you onboard new people. You can also populate packages with data grids. So a lot of reasons that you can sometimes have maybe a manifest file of the contents of your training set. That's easy to visualize here. And there's a bunch of no code and low code ways that users can interact and explore things like model performance over time or other critical model metrics. And these visualizations, we incorporate a bunch of open source libraries like Vega and Vega Lite, which allow you to build custom visualizations. You can even execute Jupyter notebooks directly in Quilt, so fully programmable in that way. And let me just check chat here and make sure. Okay, great. And I'm going to switch back to the presentation here and wrap up and then leave some time for questions. So Quilt 3 catalog is how you can browse contents in S3 and really make S3 visual and reusable to larger teams. The catalog is single player. We do have also an enterprise data catalog you can license if you want a multiplayer catalog. So the key thing here is that as you build these data sets, which includes models, training and hyperparameters, that they should really include the full provenance of the model. Excuse me. So every data set needs to answer the question of where did the data come from? Why should I trust this data? How do I use this data? And how do I reproduce the model? And the answer to how to reproduce the model is there should be a recipe for every model, which is a pure function of at least 3 variables: code, environment, and data. Example data packages, I'll leave here are the links. I've just shown you what they look like. Last, I just want to make a few points about things like feature refinement. So one of the biggest problems in enterprise is this concept of data modeling. And the wrong way to think about data modeling is, hey, I need to think of all the possible feature vectors we're going to need and come up with a comprehensive schema for that. Or there needs to be one schema that works for every data set in our organization. That is prohibitive from a cost and time perspective. And what we really want to do at Quilt is introduce this concept of organic discovery, that you roll a snowball, you just have an idea that you reflect in a Quilt package, and then you gradually harden those packages over time, and you're implicitly, through Quilt workflows, you're implicitly hardening that schema. So you don't need to know the schemas up front in many cases, especially for blobular things like training sets, which have a lot of unstructured or semi-structured data in them, but you can gradually discover them over time so they can be loaded into the data warehouse. And this process is also reflected in this idea of a bottoms-up data lifecycle that works across S3 buckets. And I've talked about this a little bit earlier. I think the main point I want to make is that most systems, data catalogs, data lakes, data warehouses have been top down, and they never really accounted for how users think about data, which is in terms of files, which have no structure, uncertain structure, and those slowly need to be rolled into a format that works for the data warehouse. I just want to kind of end here with a quote from one of our customers that really the strength they see in model governance is data versioning, because this allows them to link to an exact and correct version of any analysis. And the key word here, it's amazing. We went through all of these technical points to really get to a very human point, which is trust. And because of this totally nerdy feature, which most people shouldn't care about, which is data versioning, their scientists can really trust the data, or their bioinformaticians can really trust the data and share it directly with scientists. Why? Because it's hashed, because it's versions, because it's visual, and because it's verified. And the last point I'll make before opening up the floor for questions is really on verification. So if many of you are in GXP environments, and there the stringency, because you're manufacturing things that are going to be injected into people, the stringency on the data that you produce is very, very high. And immutability gives you the confidence and gives your auditors the confidence that the data have not changed since they left the instrument, right? Because there's a tremendous amount of conflict of interest in the drug discovery process where, unfortunately, humans are incentivized to fudge numbers this way or that way. But the key thing with immutability is that you now have a cryptographic guarantee that this chain of custody of the data from the instrument to the pipeline, to the scientist, to the filing hasn't changed. And that's really the beauty, and I think the next generation of what I'll call trustless systems will bring to bear. So I know I've said a lot there. I really look forward to your questions. I want to emphasize that all of this is super practical. I've shared our GitHub repository, which you're welcome to visit. And you can also go to quiltdata.com/AWS and learn more about how you can use our open source libraries to build an immutable chain of trust in your organization.
Awesome. Thank you very much. I'll start with the questions. We have a lot of questions, so I'll quickly move to the first one. Is it possible to keep multiple files from same experiment under same hash so that I can extract data from same settings in one go?
Yeah, this is the key point, right? And so this is what makes Quilt 3 install different than getObject from S3. getObject gets you one thing, but the package is a collection. You can have as many files as you want under one hash.
Awesome. Why do you think we haven't been able to develop a framework to make data fair?
This is the kind of the problem that because fair is a destination, not how you get there. So that's so fair is just, and by the way, just to take the pressure off everyone, all of your data is never going to be fair. You just have to get fair enough for the operations that you are undertaking for a specific initiative. I think we've had the wrong abstractions, and we try to make FAIR inevitable with packages, because if you just package the data, you've already got the metadata, the charts, the documentation, and the lineage. But I guess it's too much to expect FAIR to also solve the problem of how we do it. And we need to recognize that FAIR is a destination, but again, it doesn't tell you how to get there. We're trying to answer that question with these data containers that we call packages.
Awesome. I loved your answer. That was really cool. So the other question, are some industries more guilty of full data than others? I'm curious because Colt has experience across different sectors. Also within life sciences, do you see evidence of some groups like discover, translation, clinical, etc., being more fair than others?
I love this question. So across industries, I think it's relieving to say that everybody's data is equally horrible. So across industries, no, but definitely discovery, translational, clinical, 100%. And so there's a really, really interesting tension here. The pressure on discovery is run experiments, run experiments, run experiments, run experiments. The pressure on clinical is get it right, document it, get it right. And those are total opposites. And so one of the biggest problems that we want to solve with data lifecycle is how do you allow for creativity at the discovery phase, right? And why is that important? Because discovery, you're doing 1 million experiments, one might work. So why is anybody incentivized to care about an experiment? The problem is by the time you get to clinical, you're going to be like, oh no, one of those did matter. Like, let's go find it. And so this is the idea behind data lifecycle and this data hardening, is that you can still, in the early lifecycle buckets, you can be creative and don't have to worry about schema, but the data are still there and you can harden the schemas later. So beautiful question. And I think there are competing concerns between discovery and clinical, and we need to harmonize those with packages.
Awesome. And the last question, can we handle multiple versions of the same experiment?
You can. And so we have a lot more work to do on data lineage in the open source, but in the catalog, you can see that as you revise a package, as long as you keep the same package name, you get different versions. So there is a revision history for the descendancy of the data. And there's more that we'll do in the near future.
Awesome. Thank you very much, Anish, for the fantastic talk. I'm sure we'll learn new things. And please do check Quote's tech offering in a virtual booth section in the lobby. By that, thank you. I think I'll start. Yeah.